Right, so this problem is using force equals mass times acceleration. So let's have a look. So we've got a particle that's projected vertically upwards. And let's draw a diagram. That's always a good place to start. Okay. Put some actions like that. Okay. It's projected upwards from a point A with a speed of u meters per second. A is 17 meters, 17.5 meters above the ground. So it's projected upwards and it ends up below the ground. So on its way up, it's traveling at u meters per second. And the particle moves freely under gravity until it reaches the ground with a speed of 28 meters per second. The ground is so soft that after P reaches the ground, P sinks vertically downwards into the ground before coming to rest. The mass is 4 kilograms. That will make it 4 kilograms. 4 kg. Okay. The ground is assumed to exert a constant resistive force of 5,000 newtons. Okay, so we want to find the vertical distance that P sinks into the ground before coming to rest. So we are trying to find this distance. Okay, right. So let's have a look. So we know we've been talking about force equals mass times acceleration. So can we use that? So let's imagine our object. Okay, so we've got our object. It's got a resistive force of 5,000 newtons. Okay, and then it's basically moving in this direction with the force of gravity. Remember, basically, once a particle has left, it's moving freely under gravity. Gravity is the only force. So let's set up our force equals mass times acceleration. Okay, so what are the forces? The forces are, if we resolve vertically down, okay, then our force 4g is positive and 5,000 is negative. Okay, then we've got mass times acceleration. Well, the mass is 4 times a, and a we've got to work out. Okay, now the reason we work it out from this point where it leaves A and it's moving vertically until it hits the ground, we know what the acceleration is. We know the acceleration is 9.8. That's gravity. Now what we're interested in is this part here where it hits the ground. Called the grass. There's a grassy ground. Where it hits the grass, we're looking for this bit here between hitting the ground and then ending up underneath it. So let's work out the acceleration from this. Okay, and that will basically then be our acceleration at this point where it's broken the surface, because that's where the frictional force of 5,000 newtons starts. So when it hits the ground, we're going to have 4g, which is 39.2, or 4 times 9.8, minus 5,000 equals a. So we subtract that, we get minus 6,201.05. That's equal to a. Okay. And then when we work out what that is, that's minus 1,240.20, and that's going to be meters per second. So that's our acceleration. Okay, now, like we said, we're resolving downwards. Now, remember before, just like we did for this loop, when we want to find the peak at the top, we find our apex, we set v equal to 0 because the velocity is decreasing and then it starts to fall. Well, the same thing here. It hits the ground at 28 meters per second and slows down until it finishes. So we're going to set v at 0. So what we'll do is we'll do v squared equals u squared plus 2as, because we have an acceleration that we just found. We have an initial speed when it hits the ground, which is now 28, and we've now decided that basically what happens is we want to know where it comes to rest. So now we've got that. And the only thing that's left is the thing we want, is distance. So that means that 0 equals 28 squared plus 2 times our acceleration times s. And the acceleration is minus 1240.2. And that comes from the last part. And now what we have to do is expand this bracket and then move it to the other side. So we're going to get what? Let's do this in 2 steps. So we've got 0 equals 28 squared. No, this is going to be minus. So let me expand the bracket so it's going to be minus. Minus 2,480.40 times s. Take that over to the other side. 248.4 s is equal to 28 squared. Okay, and if we then divide by 2,480.4, you get that s is equal to 0.316. Now remember, this is displacement, so that's in meters. Okay, so what do? We used F equals ma. We looked at the point where our object has already hit the ground and it's going underneath. So that basically that lets us use the force of the resistive force of 5,000 newtons, and this initial speed, the speed that hits the ground, was a 28 meters per second. Okay, we work out the acceleration as it's slowing down. So that, remember, that's a negative because it's basically decelerating once it hits the ground. And then we use the same thing we did with the apex of the curve, the fact that v will be 0. We link together the 3 things that we know, and we find out s, which is our final answer. That's taken care of.